Hi, everyone. I'm just going to say, Nick, I don't know what your excuse was. I knew that I was going on stage, and hopefully I'm not muted, right? So, hello, everyone. My name is Isaac Goldstand, and in my previous position, I was working at a company called Amdocs, a rather large company. And at Amdocs, they've really spent like the last 3-4 years really ramping up into the DevOps philosophy, right? Something that's really been bubbling. And at some point, circa 2019, they made the decision, okay, DevOps, this is happening. It doesn't seem to be a passing fad. And we need to get into this. And then, over the last year, 2 years, a lot of the early adopters for all the buzzwords, right, started coming up with the idea of platform engineering, which for me it's not something new. For me, we've been doing business like this for more than 20 years, but it kind of really started coming in the last 3 to 6 months. I've been seeing all over the place on YouTube and on forums and on Medium. Is DevOps dying? Is DevOps dead? Right? And for the people way up at Amdocs, at least, it's kind of scary talk. They're like, wait a second, we just kind of went all in on training our people up for DevOps, and now everyone's saying this is going to die. It was a passing fad, right? What did we do wrong? And I want to kind of take the next 20, 25 to 30 minutes to set the record straight, on DevOps and platform engineering and how I really see them working in synergy and using Terraform. So why Terraform? Because in at least our world, right, Terraform was something that we've been skilling up all of our DevOps engineers, right? Those people that have gotten to the top of the salary brackets over the last few years, because you can't do production today without DevOps, right? Or at least until platform engineering came along. But right, we have these people. We've been spending so much time and effort, right? Including DevOps in the full stack, right? So it's not so much about just front end, back end. It's front end, back end DevOps, or sometimes back end DevOps, and front end, kind of has its own thing. And we've been teaching our developers, right? We've been taking a principle that I believe AWS coined, right? You build it, you own it. And that's how we're able to see this massive scaling across large organizations of lots of small teams kind of owning their own environments. Unfortunately, sometimes in the real world that just doesn't work. And I'll give you a quick example. So at Amdocs, one of the things that I was responsible for was building a cloud platform that would host all of Amdocs applications. And this was the first time that we were starting to sell existing applications on a public cloud that we hosted. That's just how we worked. And as part of that, we had to create, like I said, this massive platform with a lot of heavy regulations. So one of the regulations was that for every time an application was deployed there, the application team would kind of have full control over their own little area, but they couldn't control everything. So one of the things that they couldn't control was networking. Okay, we ran on AWS, and we needed, in order to have a VPC or a virtual private connectivity, right, network connectivity, you could kind of create your own, but you wouldn't have internet connectivity. So to connect to the internet, you would have to come to the platform team or the CCOE team, right? It might be called different things in different organizations, and only they could create that network connectivity for you, right? And that's kind of different than what happened in DevOps, and the idea of you could just do everything you want. And you can see that here on this pyramid that I'm showing, right, which shows the entire stack. And you can see that kind of at the top of the stack we have the classic application development, right? And then at the bottom of the stack, we have all the infrastructure as code tooling that we use to create the infrastructure that you guys are going to need to host your application. But in this case, that wasn't quite it, right? Because some of the infrastructure, for example, databases, load balancers, whatnot, could be created by the existing DevOps teams. However, other infrastructure was not creatable directly by them and had to be done through the central organization. And in order to do that in an intelligent way, right, we said, let's create a REST API. And I actually kind of want to give a shout out to Yaniv Iluz, an ex-colleague of mine from there. And he was the first guy that kind of just implemented this principle that I'm about to share with you guys. And for me, it was, a coin drop. I was like, of course, this is the only logical way to do things. So shout out to Yaniv. And what Yaniv did was, Yaniv said, well, wait a second. AWS already exposes APIs, right? And our developers know how to use it. So why don't, rather than sending us emails and creating tickets and whatnot, let's just create a REST API to do the work that we need to do. And this would have several advantages, right? First of all, white box, black box. So the developers wouldn't necessarily be able to see or be concerned with the details of how that network connectivity that they were asking for was actually working. It was also separation of privileges, right? Because as an organization, we decided that granting this internet connectivity was a very privileged administrative operation and not everyone could do it. And also, equally importantly, it made for separation of state. So Terraform has a state file, right, for every Terraform module that you create. And every time you do Terraform apply, that changes an existing state file. So here we said, we could have gone the route perhaps of Terraform modules, but we really didn't want to have that mixed state. We had a clear separation of state so that each team, right, the central platform team, the CCOE team, and the application teams would kind of have this separation, and each would control the state that was responsible for it, and also be responsible for that infrastructure. And so those of you in the audience with eagle eyes might be saying, okay, but a REST API, that's not Terraform. And Isaac, you promised us to talk about Terraform. So how does Terraform fit in? People who've worked with Terraform, which I'm hoping there are a lot of you out in the audience, have all used Terraform providers, right? Even if you're just bringing up stock, cloud infrastructure, you're using some sort of Terraform provider, an AWS provider, a GCP provider, an Azure provider, whatever you might be using, right? There are a lot of other clouds, but we're not going to go down that long tail. But what you may or may not know is that there are a plethora of community-owned providers for all sorts of things, right? And this could be for other hardware, like Cisco or Fortinet. It could be for other software, right, like CodeFresh or Citrix. It could be for managed infrastructure somewhere else, like DNS Simple or Cloudflare, which I don't see here, but I'm pretty sure is a provider, right? And so the idea is that we're going to take this graph and we're going to add your company to it, right? Rather than just exposing a REST API, which means, or any other sort of API, that's proprietary to you, which means that all of your application teams who you and your company have spent all this time and effort and money hiring or training to know how to use Terraform, we're just going to say, hey, you can use Terraform. Now let's see what this looks like. So when you're writing Terraform, right, you have this provider stanza, which defines a provider, right? And this it's just a dummy provider. This is actually a real provider, by the way. You could go to the Terraform module repository and look for the dummy provider, and you will see how to use this provider. And inside of the dummy provider, we have a resource called a thing, right? That's a really cool name. So this little Terraform snippet defines that we're going to use the Terraform provider. It gives an alias of foo, and it says that we're going to create a thing, and it passes the parameter that the name of this thing is going to be bar. Right? And this is how, this is just generic Terraform so far. So if you guys use AWS, you probably have somewhere a stanza saying provider AWS, and you have resources like AWS S3 bucket or AWS load balancing, or whatever it is, right? Or if you use Azure, the same thing. You'll have Azure underscore, GCP underscore, Fortinet underscore, or your company underscore. And that defines a provider, and that provider lets us use the resources and the data that's in the provider. Now, behind the hood, under the hood, what's going on is that a provider has to give you CRUD. This slide didn't go. Thank you. The slide has to give you CRUD operations, right? So that's create, read, update, and delete. It also has to manage authentication. So if your REST API is authenticated, and hopefully it is, right? Because in our example, we wouldn't just want some random dude on the internet who knows where our API endpoint is to start doing these privileged network operations. And that's what a provider does. It kind of it's the glue between this API and Terraform specific resources. And actually, the Terraform or HashiCorp has created the Terraform plugin SDK. I think they're at version 2. In the rest of this talk, we're not really going to do a deep dive into how to write these providers. There are some great, I don't know if anyone gave one this year, but I know last year there was an amazing presentation here on HashiTalks, which you can look for online, of how to actually go about writing the provider. But we're going to try to keep it a little bit high level and more abstract, just so that we understand why you would want to do this, and kind of understand what it would look like. So that when you get to writing your own, you'll have some kind of understanding of what you want to do. And so for an example, we're going to take an example, and I'll have the link for you on the coming slide. The code here, which I really hope you could all read, is for a provider called HashiCups. And this is it's a demo provider that exists. All the source code is out there. You could find it in the HashiCorp Developer Center. And in this example, you could see this has nothing to do with infrastructure. We are writing a Terraform provider to service coffee. And you can see that we have two types of coffee in this order, and you can see the highlighted lines with quantity. So in this example, these are the lines that we're showing. So I could have started with a brand new apply, but I'm only going to have time for this one example. And I really wanted to zoom in on as many steps as you can. So rather than apply from scratch, which has no existing state, I wanted to do a mutate operation, because as you're going to see, the mutate operation has to do several things. So why does it have to do several things? Let's kind of think about this logically. When you go and mutate a resource that's managed by Terraform, the first thing that Terraform is going to do is it's going to look for the state file. Right? That's how it knows that it's a mutate and not a create, because the state file says that there should be something. And then for everything in the state file, we're going to want to make sure that we don't have state drift. So the next thing that we're going to do is we're going to go to the providers, right? It could be the AWS provider, or it could be your company provider, and it's going to query those providers. Hey, I have these resources. So in this case, it's going to have this item resource with coffee ID 1 with some quantity, and then it's going to have another item resource with coffee ID 2. It's on a really small screen for me, sorry. And it's going to look for that also. And let's see what that looks like. So in the next slide, I'm going to show you some logs of what happens when we do Terraform apply. Okay, and as you can see here, we have 5 actions that we're seeing. So the first thing that's going to happen when we go to a provider is we're going to have to authenticate, right? And this happens with most providers that deal with back-end APIs. And there are lots of different ways you could configure it. Classically, the ways to configure it is either through explicit configuration. So in that provider block that we saw before, you could have some API key or username and password or whatnot. Or you could read it in in your provider. You could have it read it in from the environment variables or from a well-known location, where you have a dot file or some other file that has the configuration in there. And the first thing that we're going to do is we're going to go log in to your REST API and get a session. And the second thing that we're going to do is, after we've looked at the state, we're going to compare the state. So you could see here we're doing get user order, right, which is going to look at the state file for those 2 coffee items and compare it. And that's one operation, and it ends there. Then it's going to immediately create another session for the mutation, right? This is once you've said yes, or unless you've run apply minus y, in which case it'll kind of run together, right? But when it asks you, do you want to apply it? This is where that second sign-in happens. And then you can see that there's a gap, because in this example it did some other things, and eventually it came around to mutating our order. And you could see the API call for that is update order, right? Which is exactly kind of what you would expect in a CRUD API. Now, also, if you want to build your APIs in a modern and friendly way, right? Typically, your modification APIs aren't going to be blocking calls. Rather, you're gonna get some ID, or if it's create, you'll immediately return an ID, and then you're gonna expect the user of your API to pull. And Terraform works exactly that way. So you can see after we did the update, it's gonna call the getter again, and it's gonna look at the status of this, and it's going to see has this really been created, and is it up to date? And the same kind of exists for create, right? So if we were doing a state file Terraform apply for the first time, what we'd probably see here is just a sign in and then a create order, right? And then that would also be two API calls. You'd have a create, which immediately returned an ID of everything that you were doing, and then you would have a get. Now, I want to kind of concentrate, rewind, and focus on that last statement that I made. Just create and return an ID for everything that you're doing. So every single resource is going to have a unique ID. That's kind of the contract that Terraform expects to have with your REST API. And it's also kind of common sense. Every single resource that your API is capable of giving, and the platform engineering team, you understand how what level of abstraction you want and what level of detail you want. So it could be that for your networking, you have an ID for the virtual private network, and you have an ID for the route table, and you have an ID for whatever peering or connectivity that you might have between your network and the network with the internet, right? To use the example that I've been going with the whole time. But it also could be that you want this entire networking bridge to kind of just be its own abstract unit, and you don't want your application developers or the DevOps developers who are building the applications on top of your platform to have to deal with that level. And in that case, you could have this API call that just gives this master ID for a bridged VPN, and that's all you give back. And it's really up to you as the platform engineer to decide and define what the interface that you want to expose it. Now, before I get to the next slide, another point that I just want to kind of touch on is, okay, so why use a Terraform provider, and why not use just a Terraform module? And the truth is that in many use cases, you can use Terraform modules, right? I'm not saying that everything needs to be done with a provider, but a provider will have several aspects of clear separation of responsibilities implied by them. Right? I touched on them earlier, I'm going to say them again. So the first thing is, right, it's closed source, or if you want it to be closed source, you could inner source it, open source it, but it's not automatically open source. So when you use a Terraform module and publish it, and someone consumes that Terraform module, the first thing that Terraform is going to do is it's going to fetch those Terraform files that compose of your module, and it's going to put it into your working directory, meaning that the users of your Terraform module will always have full transparency to understanding exactly how it works. And this also applies to module nesting. If there's nesting, it'll start fetching all of those modules. If you have any reason or any concern for which you'd want to hide that source code, then a provider is the way to go, because a provider is written in Go, and it's distributed rather than in source format, it's distributed in a binary format, and therefore that's not available. Another difference is that the state file is going to be separate, right? If you wish it to be so. As a matter of fact, it's even beyond just the separate state file. No one says that your provider, right, whatever's hiding behind that REST API, even has to be using Terraform. In our case, it was. but you could be abstracting several other things. You could even be orchestrating several things. So you could have a provider that provides a My Company application. And when you create that My Company application, it could vend a cloud account, set up, the landing zone for the cloud account, create a Kubernetes or some other cloud orchestration, a load balancer, CDN, right, a database, and these don't even all need to necessarily be in the same cloud account. So you could really abstract all that information once you're using a provider, because you have absolute freedom to figure out what it is that you want to do. So putting this all together, right? If we look at this pyramid again, right, we could really see this clear separation using Terraform, kind of smack in the middle of the chart here, right? So the top is still kind of the application developer, right? And this is where you'd still keep those DevOps staff, and that would be their domain, right? And on the bottom you have the platform tools, and those could still be using whatever you want. It could be Terraform, Chef, Puppet, Ansible. It could be your own Python or Node.js code that's making REST calls to wherever it is you want, right? You really define that in the middle, and that still gets exposed as a REST API. But rather than your DevOps or your application teams kind of needing to skill up and learn more about whatever technology it is that you bring, here you're kind of going the extra mile and saying, here, I want you to consume this as a Terraform provider, right? And that'll have several advantages. It'll have the advantage that your DevOps people already know Terraform, or at least we hope they do. It'll have an additional advantage of the fact that your application, the DevOps people that are on the application team will presumably have other fine-tuning to the infrastructure that they need to do. And you could still have this shared responsibility model where the platform team has complete ownership over the infrastructure that they provision, but you still have the flexibility of giving those application teams the ability to fine-tune and control whatever they are able to do. I think I'm running a little bit early, but we're gonna end here. People out there in YouTube, I will be around for the next 10-15 minutes to field questions. As a matter of fact, we'll take a look now and see if we have any questions here. And the MCs, as soon as you guys want, you could feel free to hop right in, because we're wrapping this talk up.